Hello students, I am Sayon Dey from the Department of Mechanical Engineering. Today I am going to discuss about the welding processes. Actually, I have made a PowerPoint presentation on behalf of the first year syllabus of MAKAUT and the Brainware University. Okay, and according to the syllabus, I am covering the topics that we will discuss in our welding shop. Okay, basically this is the theory portion of our welding practice. At first, I'm going to the definition. Basically, welding is a joint. Okay, mainly joints are two types, that is permanent joint and temporary joint. But welding is a permanent joint. Another types of joints are there. That means adhesive joints, mechanical joints. In the adhesive joints, the most popular joint is the using of glue. Okay, that means adhesive. This is a type of joint that is called adhesive joint. Okay. Another joint that is mechanical joint, and in this case we mainly use nut and bolts. Now I'm coming to the main definition, that is the joint of two metals or non-metals permanently, and similar or dissimilar metals can be welded. Okay, we have to use the heat for the welding, and there are several options like the filler, using or not using the filler metals, pressure, and the flux. Okay, for the welding process. Another important word, that is collisions of two materials at joint. This is very important in case of welding, because there should be a mechanical similarity of the in case of properties. Okay, for welding. Next, through a block diagram, I'm going to discuss about this slide. That is the I have already told that by using the heat, we have to melt the metal, and we can join the metals. That is called welding. Okay, there is a there is an option for the filler metal to use, but this heat can be generated by various ways, like electrical current. Okay, for the arc welding, gas for the gas welding, chemical reactions for the thermit welding, laser or ultrasonic for the laser welding or ultrasonic welding, for the friction for the friction stir welding, and others are also there. These are the mainly the procedures to generate the heat. Okay, nothing else. I'm going to my next slide, that is the main welding definition in short. So it is the process of joining similar or dissimilar metals with or without application of heat, with or without application of pressure, with or without application of filler metal. Okay, one thing is missing in this definition is that there is a option for the use of the flux also. Okay, and here is written that with or without application of heat, but I want to say that in case of every welding we have to apply the heat. Okay, please correct these things in this uh, definition part. Next important part, that is weldability. Basically, weldability means the ability of welding of a metal. Okay, this is called weldability, and this depends on various points like melting point, thermal conductivity, thermal expansion, surface condition, change in microstructure. These are the uh, points that depend on the weldabilities. Okay, I'm not going in detail of the weldability. Next, actually this is the basic metallurgy of a welding. Suppose this is a welding portion. If we cut this section, so we can see there are various parts in a welding. If we see the microstructure, okay, basically uh, in this zone is called hash, that means heat affected zone. Okay, that means main fusion takes place after this, and we can see there is a graph also. Okay, this is a cooling curve. Okay, that means the heat will be reduced when we get a distance from the center. Okay, and another important thing is that we can see in case of this region and this region there is a difference between the grain sizes. In this section we can see porous grains, but in this section we can see the grains will be elongated and uniform. Okay, this type of changes occur when you see the microstructure. Okay, so as per your syllabus I'm not going in detail about this, just note it down that the has is the heat affected zone. Okay, next, there is the types of welding and welding joints. Okay, I'm going to my next slide to discuss about this. That is these are the types of joints. At first, in this section, we can see there is a joint. This is called butt joint. This is called fillet or T joint, commonly known as T joint. Another is corner joint. This is called lap joint. It is called strap joint. Next, these are the common welding positions. Okay, this is the flat position, horizontal, vertical, and overhead. Okay, and this direction denotes the increasing the difficulty level. Okay, that means the overhead welding is more difficult than a flat welding. Okay, next, that is the welding terminology. So I'm going to discuss about the basic terms that we use during the welding. In the left hand side, we can see there is a welding that is the called butt welding or butt joint, and there are other points are there like the base metal. These portions are the base metal. These are the fusion zone. This is called root. This is the root opening, and this portion is called root face. And there is a upper side of this joint that is called reinforcement, and the upper face is called well breed. Okay, and this is another joint. This is a corner joint. We can see here also the points are there. Another point that is missing in this picture, that is the toe. Actually, toe is the junction of the well breed and the base metal. That means this part, this is shown here. That means this part is called toe. This is the main terminology of welding. Next, these are the edge preparations. Basically, for every welding, we have to prepare the edges before performing the practical work. Okay, so to prepare the edges, there are several conditions, and the specific notations are there, like the VU, W, WV. All there are certain angles to prepare the edges. All the angles are shown here. Okay, you may follow it. And one thing I want to say that please pause my video to every slide and note the important points. Okay. Next, these are the various types of weldings. Basically, welding can be divided into three parts. That is solid state welding, liquid state welding, and solid or liquid state welding. Okay, and this portion is under the brazing soldering part, and in the liquid state welding there is mainly the arc welding, resistance welding, gas welding, thermit welding. Okay, and in the solid state welding there are various type of weldings. Actually, in the first year workshop syllabus, only according to that syllabus I am discussing about the arc welding and the gas welding, and also we are going to discuss about the resistance welding and spot welding. Okay, so I'm going to my first topic, that is the gas welding. In case of gas welding, we have to use the mainly two gases, that is one is oxygen and another is acetylene. Okay, and here the oxygen acts as a fuel gas. Why? Because it has some welding operations. Like commercial gases, gases have one common property: they all require oxygen to support the combustion. to be suitable for the welding operations. Okay, but a fuel gas when burnt with oxygen must have the following, like the high flame temperature, high rate of flame propagation, adequate heat content, and the minimum chemical reaction of the flame with the base and the filler metals. Okay, so these points we have to remember before performing any welding operation. Okay, next is our main thing, that is the acetylene welding. This is our main objective to do in our workshop. So I am not reading all the lines. I'm going to the main thing, that is the, in case of this type of welding, I want to show you one small video of gas welding. Please wait. Yes, uh, there are mainly two parts we can see in this video. So we are trying to join the edges. We can see there is a metallic part, but there is a whitish part. Okay, actually we have prepared the edges to join, and there are several processes to prepare the edges, like the cleaning and uh, and other steps are also there. So we can see in this video that there is a holding device. We are holding our main job, that means two parts. This is the electrode. Okay, actually this is a filler metal. Okay, nothing else. And this is our main welding is going on, that is the gas welding. Actually in this this is the torque, and here we can see, we cannot see, there are two cylinders. One is oxygen cylinder, another is acetylene cylinder. Okay, and by the mixing of two cylinders we are doing this welding operation. Okay, we can see the welding is going on. This is called, this is a gas welding, oxyacetylene gas welding. Okay, and the stick that is holding in a left hand, that this is the filler metal to fill the excess metals in the joints. Okay, okay, we can see the welding. Okay, okay, okay. Next, this is the main torque, and this is our cylinders. One is oxygen and another is acetylene. And through this oxyacetylene gas welding, we can see mainly three types of flames: neutral flame, oxidizing flame, and carburizing flame. Okay. According to the percentage of using the oxygen, we have divided the flames into three parts. There are certain differences between these flames. Like this neutral flame, we have to use the oxygen and acetylene into 1:1 ratio. Okay, that means there will be equal the amount of oxygen with respect to the acetylene. Okay, in case of oxidizing flame, okay, the percentage of the oxygen will be greater than the percentage of the acetylene. And in this case we can see the reverse, that means the acetylene will be more with respect to the oxygen. And we can see the several differences between this inner cone. This is called inner cones. Okay, in case of carburizing flame we can see a bright cone. Okay, and this is called feather. The temperatures are also different. Like you in neutral flame, the temperature we can get 32,000 degrees centigrade. Okay, other differences are there. Mainly I want to discuss about one thing, the main chemical reaction that occur during our oxyacetylene gas welding. Okay, then what will be the chemistry behind this, the reactions? Basically we have divided the entire reaction into two parts. At first, in the first stage, basically acetylene and the oxygen reacts and generates the heat, and in the secondary stage, uh, CO and H2 and O2 reacts and also generates the heat. And if we combine these two, then we can get this type of equation. Here we can notice one thing, that the 5 parts of oxygen is necessary to consume 2 parts of acetylene. That means this, and we are getting heat. Okay, and by using this heat, we can melt the metals and can join and do our welding properly. Okay, so this is the oxyacetylene gas welding. Okay, there are various procedures to perform this gas welding, like leftward or the forward welding, rightward, and the vertical welding. Mainly there are 3 processes. So I want to go to my next slide. So through a picture I can discuss about this topic. So at first I want to show this. This is called the leftward welding. Okay, in case of this leftward welding, we can see the direction of this welding, that is to the left hand side, and this is the rightward welding, and in this case the direction of welding to the right hand side. Application of both the processes are different. uh, if we are going to join the thinner sheets, then we have to prefer this leftward, and if we want to join the thicker sheets, then we are going to prefer this rightward technique. Okay, and there are certain degrees, standard degrees, which are to be maintained during our welding. We can see this is the filler rod that should be at 30 to 40 degree. Okay, next, that is I'm going to my another topic, that is the arc welding. Okay, so in case of arc welding, there is a term, that is arc. So at first I want to discuss what do mean by arc. Basically, arc is a electric discharge that will generate during the contact resistance, okay, between the two parts. Now going through the lines, that is the A arc is generated between two conductors of electricity, cathode and anode, when they are tasked to stabilize the flow of current and then separated by a small distance. Okay, and electric arc is sustained electric discharge through the ionized gas column, that is called also plasma, between the two electrodes, and the two electrons liberated from the cathode strike the anode at high velocity, okay, generating the large amount of heat. So we can understand how much heat can be generated during this arc welding. Next, I'm going to my next slide, that is the electrodes. Actually, electrodes are needed for any arc welding. Basically, electrodes are in two types, that is consumable and non-consumable. Okay, and there should be a coating on the electrodes, and it has some several purposes. The purposes are also written. Those are to facilitate the stabilization and the maintenance of the arc. Okay, so the coating of this electrode actually acts as a guide for the arc. Okay, and it helps us to stabilize the arc. If we don't stabilize the arc, then the welding will not perform properly. Another points are there, like to provide the shedding gas around the arc and weld pool, to provide the formation of slag to reduce the rapid cooling. Actually, this slag is also in a welding defect. Okay, another one is there, to introduce the alloying elements not contained in core wire. Okay, these are the several purposes for the electrode coating. Next, I'm going to the SMAW, that is the shielded metal arc welding. This is the one type of arc welding that we are going to discuss. Okay, so before going to read all the lines, I'm going to show you one short video about this SMAW. Okay, so before this, through this picture we can see that is there should be a electrode. Okay, so we are going to see the video. Yes, there should be a transformer. Transformer is shown here for any arc welding. Here is the welder, he is welding. Okay, this is the welding process. In our naked eye, we cannot see the welding. This is harmful for our eyes. Yes, we can see the welding is going on. Through this process, the arc is generated, and basically I have already told the arc is the electric discharge that will generate during the contact resistance. That means for this process, at first we are going to touch the electrode with the metal, then we are going to separate the electrode and our job for a several distances. There should be a standard distance which we have to maintain, and then only the arc will be generated. Okay, these are the pictures. Okay, in this picture we can see this is the our electrode. Okay, you can see there are several applications of this SMAW, shielded metal arc welding. Okay, okay, so I'm going to my next slide. I'm requesting to my every student, again, please pause my video to every slide and please note down the lines. Okay, that is very important for your exam preparation. Next, this is the entire setup of the SMAW. As I have told, there should be a power source, that is the transformer. Okay, and there should be a working table, base table, and we can see there are two wires. One is the electrode cable. Okay, the electrode is attached with this electrode holder, and another portion that is coming from the power source should be connected to the table. Okay, so if we connect this to a table, that one thing, that is the table should be made of metal. Okay, so it will complete a entire circuit, otherwise the arc will not be generated. Okay, next, transformers. As I'm already told, there are two types of transformer we are using for this SMAW. One is constant current type transformer and constant voltage type transformer. Okay, so I'm going to discuss about those topics in my next video, next slide. And this is the slide. We can see two parts. Okay, one is constant current type and another is constant voltage type. We can see this type of graphs for the two transformers. Okay, next, that is another uh, example of another type of welding, that is called resistance welding. Okay, in case of resistance welding, this is a fusion welding process where both heat and pressure are applied to joint, but no filler metal or flux is added, and the heat is necessary for the melting for the joint is obtained by the uh, heating effect of the electrical resistance of the joint. Okay, this is the main resistance welding. This is the entire setup of a spot welding, as we can also see this setup in our workshops. Okay, actually there are two electrodes here. Okay, those are also connected to a power source. This is the entire circuit. Okay, and this is our job. Basically, through this setup, we can only join the lap joints. Okay, this is a lap joint. There are two electrodes that are also shown in here. These are mainly made of copper. Okay, and we are uh, forcing we are applying force through these electrodes, as well as we are supplying the current. Okay. Mm, this spot welding we prefer for the thin sheet welding. For the thick sheets, we do not prefer this type of weldings. Okay. Another points are there, like in the welding joint portion, this is called a nugget that will generate during our spot welding. Okay. This is not in your syllabus, so I'm not discussing about this heat balance portion. Okay. Spot welding, I have already told this spot welding. Again, I am telling, this is employed to join overlapping strips, sheets, or plates at small areas, and this is widely used in electronic, electrical, aircraft, automobile industries. Okay. Another type of resistance welding, that is the projection welding. This is one type of stop welding, but there is some modifications like this. Okay. I'm not going into detail about this topic because these are not in your syllabus. Another one, that is a seam welding. This is a continuous type of spot welding. In case of spot welding, we saw there are two electrodes which are made of copper. But in case of seam welding, there are two. There are also two electrodes, but the shape is different. Okay, we are using here two wheels. Okay, which act as a electrode, and this is the continuous type of spot welding. Another important welding that is not your in your syllabus, but still I am discussing because of the interest. Uh, in case of railway line joints, we use this type of welding. This is under the chemical welding portion. This welding is called the thermit welding. Okay. In case of thermit welding, basically we prefer iron oxide and the aluminum oxide and iron powder. Okay. Here is a picture. Basically, we make a mold, and in this mold we mix the mixtures, and it will generate a excess amount of heat. Okay, and through this heat, the aluminum is generated and it is melted over this portion. Basically, this type of welding is used to repair the railway lines. Okay, now I'm coming to the defects. There are several type of another weldings I'm not discussing here. Now I'm going to the defects. Okay. uh, at first I'm going to discuss about the poor fusion. Okay, this is the picture. The through this picture we cannot understand this. Okay, lack of throughout and complete union between the deposited and the present metal. This appears as a discontinuity in the weld zone. Okay, and lack of fusion is because of failure to rise the temperature of the base metal or previously deposited weld layer to melting point during the welding. This is the basic crack, not only crack, this is the basic defect that we can see through the welding. Another is undercut. Okay, this appears as a small notch in the weld interface. This is a very common defect in case of welding. Next is porosity. Basically, porosity is the entrapment of gases into the welding section or the bead. Okay. Next, slag inclusion. Slags may be included in the welding zone or in the bead. It is also a welding defect. Next, the crack. This is the most important defect. Okay, that is common for any type of welding. Next is distortion. We can see this type of bending or this type of shape. That means distortion. Okay, and there are several ways to, to overcome these defects. Like in case of this distortion, we use proper clamping or preheating to overcome this defect. Okay, another defects are also there. I'm not going into detail about this. Okay. So if you like this video, please like and share to your friends. Okay, thank you for watching.